In this video, I am going to show you how to graph a function in MyOpenMath. So let's take an example. Let's sketch the graph of f of x equals 2 times the absolute value of x minus 4, absolute value closed, minus 3. Now in this module, we've looked at several different graphs, and the way that we've learned to graph them, or graph the equations, or the functions if you like, is by plotting points. That is, setting up an xy table. So that's how I'm going to go about sketching this function. We have f of x equals 2 times the absolute value of x minus 4 minus 3. So I'm going to start by writing down my function 2 times x minus 4 minus 3. And then I'm going to put with it a table, x, and then f of x, and leave a little bit of room for scratch. We're going to pick a series of x values, domain values if you like, and then find the corresponding outputs or range values. Let's start with an easy value for our domain. Let's let x be 0. And if I substitute 0 into my function, that means that f of 0 is 2 times the absolute value of 0 minus 4 minus 3. And if we go on to simplify this, we start inside our absolute value. 0 minus 4 is negative 4, so we have 2 times the absolute value of negative 4 minus 3. And recalling knowledge, absolute value of any number is its positive value. So 2 times the absolute value of negative 4 is actually the same thing as 2 times positive 4 minus 3. Or in other words, 8 minus 3, which is just 5. That means for this particular function, we have a point 0, 5. Let's take another value in our domain, 1. 2 times 1 minus 4 minus 3 equals, and we'll go through the steps again, 2 times the absolute value of 1 minus 4, which is negative 3, minus 3. Recall again that the absolute value of a number is simply its positive value, so 2 times the absolute value of negative 3 is simply 2 times positive 3 minus 3, and that gives us 6 minus 3, which is just 3. So 1 maps to 3 for our function. We continue plotting some more values. 2 times the absolute value of 2 minus 4 minus 3 equals 2 times the absolute value, simplify what's inside, that's negative 2 minus 3. 2 times negative 2 is 2 times the positive value 2, because the absolute value of any number is its positive value, minus 3, which just equals 4 minus 3, or 1. Now I'm going to let x be 3, 4, and 5 and get corresponding y values. I'm not going to show you the work. I'm going to let you try, but the answers you should get are as follows. When you plug in the domain values of 3, 4, and 5, respectively, into your function f of x, you will get the numbers negative 1, negative 3, and negative 1. This means this function has a series of points that are on the graph, and that series of points, if I wrote them down over here, would be 0, 5, 1, 3, 2, 1, 3, negative 1, 4, negative 3, and 5, negative 1. These are just 6 points that fall on this function. Now there are infinitely many points that we could plug in. So to graph this, we're going to plot points, these points in particular, and then we'll connect them with a straight line or a curved line or some kind of a line to find the pattern and show the infinite number of points that actually fall on this graph. Now, how do we do that in MyOpenMath? This is where some students have difficulty, because this is a different system. You can't just plot these points on here and then connect them with a straight line. You have to use the tools presented to you. So what I encourage everyone to do is take these points and actually put them on your own graph, on your own paper, and then transfer that over onto MyOpenMath. So let's do that together. So transfer this set of points that we obtained from our XY table and put them onto our graph. Let's start with the point 0, 5. 0 for X, 5 for Y puts us right here. 1, 3. 1 for X, 3 for Y puts us right here. 2 for X, 1 for Y puts us right here. 3 for X, -1 for Y. 4 for X, -3 for Y. 5 for X, -1 for Y. Is there a pattern that you see here? See how there's some symmetry going on? So 6 would actually map here to 1, 7 would actually map here to 3, and what shape are we getting? Can you tell? We're getting a V shape, right? That should look familiar. Recall the absolute value function, f of x equals the absolute value of x, looks like a V. It's two lines that meet at a point. And that's exactly what's happening here with this absolute value function. So we're going to take these points and connect them with straight lines, and that will give us the infinite set of points that satisfies this graph. We connect those dots using a straight line on the left side, and then we also have a line on this side. The set of points that satisfies this function creates a V. Now our job is to take this graph, which we've graphed, and transfer it over into MyOpenMath. Look on the bottom here. There are several different graphs that it's telling you can use. We have the straight line function, we have a parabola function, we have a square root function, and here we have our absolute value function. The key that we want to use here is the absolute value key. We want to press this, and then we'll be able to graph our function. So let's do that. The first point that I want to use is my vertex point. So when I click on this, I'm going to have a point appear, and I'm going to place it at the vertex of my V. That is, I'm going to place it here at the bottom part of my V. Our vertex point appears. Now we click and we hold here, and then it will create for us a second point, this point here. So now we click and hold, and we put another point here to match the point 3 for x, -1 for y. And this will create for us our absolute value graph in MyOpenMath.